Hello and welcome to today's TRACE webinar presented by 3 Degrees. My name is Dr. Mike Vasquez, and I'll be presenting today a little bit more about what we're doing with some new software tools focused on quality management and traceability in the additive manufacturing ecosystem. So today, thank you for joining us, and we'll probably talk for about 45 minutes to an hour. There'll be plenty of time for questions at the end. So if there are questions, I think you can unmute yourself and ask them, or there's a dialog box, as well as any follow-ups. I'll share my email and contact information at the end of this conversation. So today, the aim of this presentation is really to discuss TRACE, the context and history of the tool, as well as go through a detailed look at the software, and we'll do a live demo and go through how it works and share with some of the findings that we've had so far and some of the early pilot studies that we're doing. So we're excited to launch this tool. It's been a long time in the making, and excited that you were able to join us, and thank you for your time. So today we'll aim to do kind of three things. First, we'll go over a little bit more about what 3 Degrees is, who we are, how do we help companies in the 3D printing ecosystem. We'll then go into kind of challenges in managing 3D printing quality. First, based on the number of variables and kind of the resources available, and some of the things that really inspired us to develop the tool that we'll talk about next, which is TRACE, which is a software tool to help in the quality management of additive manufacturing processes, especially as folks start to really utilize the technology for things beyond prototyping, either doing material and production validation studies or going to full production. So included in that, I'll share a number of slides, as well as the kind of tool itself in a kind of a guided walkthrough of the presentation. So just a little bit more about 3 Degrees. So we were founded in 2012. We're based in Chicago, Illinois, actually right downtown. So any of you that are coming to AMUG in a few weeks, we will be there, and welcome you to stop by our office as well. We're not about a mile and a half from the conference site. So really what we are a partner to 3D printing end users, OEMs, and material suppliers. So we act as consultants in many cases to help develop economics and strategy around 3D printing technology, more focused on the production level. We're kind of focused on developing materials and system expertise. So my background personally, I've been in the additive manufacturing space for going on 11 years now. I'm a materials engineer by background and have developed a number of different materials and different applications for 3D printing, focused on production and robust engineering systems. So we also do a number of workshops and workforce development for a variety of industries. So kind of for the last 7 years, really, we focus on technical consulting services. But now kind of with the launch of TRACE, we're moving into that software spectrum as well. So we work with a number of companies in all different fields, as I mentioned, kind of the OEMs, material suppliers, as well as end users. You can see a number of the companies that we work with here. And because of that, we sit on kind of this unique place in the ecosystem where we see both inside the facilities and working additive manufacturing spaces, as well as some of the supply chain that enables the industry, either through machines or manufactured materials. So what we're really going to focus today on is TRACE. So TRACE was a kind of concept that started almost 18 months ago, with a number of the conversations that we were having with users and some of our partners in collaboration and developing some projects. And really what it focused on was I was having a hard time as we were going through material validations and process validations that were gearing up some sites for production, of managing that data set and the number of variables that was included in the additive manufacturing process. So as many of you know, kind of depending on the type of technology, whether it's DMLS or polymer laser sintering or kind of FDM, there can be well over 100 variables that have a significant impact on how you might view the outcome of a part. So that could be in the design realm in terms of part orientation or support materials. It could be in materials selection, who your vendor might be, what batch number, your process, your inspection, and post-processing. All of that information was can really kind of bog down and busy up Excel spreadsheets that you're using to keep track of that, and that gets cumbersome after a while. And so kind of with that idea, we ended up working with, we ended kind of doing a listening tour. So we talked to about 50 different companies who are using 3D printing at various levels. We also talked to organizations who are in the standards and auditing kind of realm, kind of the FAA, FDA, some of the automotive standards organizations as well, UL, and in terms of getting some feedback on what were some of the challenges they were seeing in their perspective. And kind of the next thing that came up was there's really no centralized data source for additive manufacturing specifically. So as kind of people develop the workflow for their processes, there's data that's generated on all these different islands. You have your CAD inputs to the software, from the software. You have data sheets and safety data sheets that are coming in from vendors. You have equipment inputs and outputs, certainly on inspection of materials and parts at the end of the process. All of this kind of comes in different areas. So what we were finding is there's a lot of data coming in, but it's kind of all over the place to an extent. And certainly as facilities grow beyond just the R&D kind of space with a handful of machines, in order to scale kind of production 3D printing, you need to kind of make sure that you have a good handle on this, especially as it comes into more regulated areas. And kind of this final problem that we're hearing a lot of was that kind of knowledge transfer and data retention is somewhat fragmented. So kind of certainly there's these different kind of parts of the AM workflow. There's design inputs, there's materials, kind of the actual production of the on the manufacturing floor. So data is in a lot of different places, and communicating that out either to end customers or as needed, or going through audits. It was just somewhat of a challenge to kind of keep that all organized and keep it up to date, as well as kind of develop that in such a way that it would be easy to communicate out. So if you had to quickly prepare a comprehensive report of traceability or something like that, it usually would take a number of days to kind of compile all that data. So we built Trace as a solution to this that addresses the challenges by kind of first saving kind of both time and money to kind of have all of this information in a organized, collated, and structured kind of place. So we've kind of developed a number of guided workflows and templates that, from the perspective of having worked on facilities and operated a number of these different machines, we know how the systems operate. We know kind of the kind of level of detail that's required to go through audits and validate processes and materials. So we've kind of taken that perspective and say, okay, how do we make that and distill it into a way that's communicated easily throughout a workforce? We've also built Trace to help ensure compliance. So Trace follows kind of industry standard best practices and are regularly updated to reflect changes in standards and development of standards. So we sit on a number of the kind of trade organizations, such as America Makes, and we're part of the ANSI kind of development of some of the standards roadmaps. So we're very familiar with a lot of the development of standards. So we try to incorporate kind of what the best practices are, so that hopefully saving kind of organizations time and kind of reviewing those and kind of outputting the data and workflows that are required and recommended for many of these guidelines. And then finally, kind of because we're creating this digital thread of information that can be attached to every project, every part, we're really creating part traceability throughout the entire life cycle. It doesn't stop when it ends, kind of leaves the build chamber. We're looking at things like post-processing, what was done for heat treatment, or what was done for inspection, so that we're really keeping track of all the different variables that are going into the process. And then at the end of the day, you have a digital thread that kind of can be connected to the physical part. And we'll talk a little bit more about what we're planning to show and demonstrate on that. So in terms of the concept, Trace really enables users to streamline the project management and documentation process at all aspects of the 3D printing workflow. So it was developed kind of through our expertise in operating machines, developing kind of materials and process parameters, as well as setting up facilities. And we've kind of demonstrated that it can be kind of customized depending on what the particular use case might be, whether it's an industry specific use case or a technology specific use case. So when we go to demonstrate the actual tool itself, I'll show more about how it can be adapted to a DMLS system or a polymer laser sintering system or multi-jet fusion or something else. We'll kind of show how it's kind of demonstrated that way. And really the value that we feel that we've created with this, and the feedback that we've gotten with some of our pilot program users, is that it's a much easier way to archive critical AM data in an organized way, and kind of steps through some of that process of really making sure that you're not boiling the ocean in terms of everything you need to document, but making sure that it can tell a story, and tell a story that's effective and easily kind of scalable. It minimizes the time to qualify a part and kind of time to market, because you're not wasting time on compiling all this information, making sure that you have the right data for specific audits. Additionally, it hopefully increases workflow and repeatability, because we're tracking a number of inputs such as particle size distribution or lot number of the material. So if you have an issue and you can kind of trace it back to specific factors, maybe you had a bad lot from one of your vendors and the last batch of 10, 15 parts wasn't coming out correctly, you'd be able to quickly identify that and trace that back to a specific build date or specific kind of lot number, and quickly identify what was the issue, and perhaps save some inventory and not scrapping everything. And kind of the additional thing, because this is a software tool, we built a lot of the functionality in already. You're not wasting a lot of time building this from scratch. We can deploy this either in the cloud or behind specific firewalls and have it locally. So there's two options for folks depending on what might work best. And so as we've gone and developed the tool, we've wanted to quantify, okay, what is the actual value of having Trace? So one of the things that we really wanted to kind of emphasize is this idea that you want to focus your engineers' time on developing new concepts and new approaches, and not paperwork. So we did some calculations based on average kind of employee kind of wages in the engineering field, based on if you're doing about 10 builds per month, and how much kind of time it takes to collect some of that data, and the amount of data that we're collecting in Trace. So we were able to kind of show that just in time alone, we can cut time to compile and present and evaluate and export all this data by 75%. And if you look at kind of how much time that would be in actual engineering hours, it'd be close to $8,000 annually. And in addition to kind of conceptually what we're doing with Trace, what we've looked to incorporate as much as we can, especially at this early launch date, is that there are no shortage of organizations working on standards and development of those standards for additive manufacturing specifically. If you're familiar with those, it's kind of a crowded space, but there are initiatives by American Makes, SAE, UL, ASTM, NIST, certainly, to kind of develop some standards. So we've done the kind of legwork and reviewed many of those standards are incorporating those into Trace so that you can track along with what the current best practices and what the standards are saying, and those will continue to change. And certainly depending on what industry, if there's industry specific guidelines, we've done our best to incorporate those into the tool as well. And we've also had some case studies. So one of the early case studies we've demonstrated was with the Quad Cities Manufacturing Laboratory at the University of Western Illinois. So they took some of our, we essentially gave them the tool and worked with us to kind of go through a production build, documenting all the different steps, and built some parts out of 316 stainless, really to help and demonstrate how you might be able to use the technology to look at measurement traceability, kind of what are the requirements for productions and services, how would you look at it for an internal or external audit, and certainly for identification and traceability. And one of those things that we're also incorporating, we'll show more at AMUG, is how do we actually connect the parts to this digital information that that we've been generating. So we'll show kind of some of the marking systems that we've incorporated into the parts, so you'll be able to quickly scan a part and pull up the full historical record on that component. So what I'd like to do now is kind of switch gears a little bit and show you the actual tool, because I think that's most informative to what we want to show today. So I'm going to exit out of PowerPoint here and go over to the Trace app. So just to give a sense of kind of what this looks like. So this is the Trace dashboard that you would get on login. So kind of taking a step back, as I mentioned, this is the cloud version of Trace, and certainly we can deploy it locally as well. And one of the things that we're aiming to do is kind of conceptually is that every user, every organization that is kind of using Trace would have their own server, kind of that be proprietary to them. It'd be secure, and kind of the best practices of our development team, many of which have worked on projects for the Air Force and other DoD institutions. So we're well aware of kind of strict kind of concerns with data management and capture of that data. So that's at our highest priority. I'll talk a little bit more about security towards the end of the presentation, but just to keep in mind, that's something we take very seriously, and it's something we've integrated in into the tool. So kind of upon login, what you'd see is a kind of a dashboard that shows a variety of kind of different things on here. So I'll kind of walk through these as we go, and some of these are going to be tightened up and shown a little bit more kind of polish at AMUG in a few weeks. So we're working on a few final touches, but much of what you see today is integrated in and will be kind of incorporated into the first commercial release. So as you go through the dashboard, kind of what you would see up on top is kind of what projects are complete, which ones are active. You'll be able to kind of review kind of just over, okay, how many are in the queue and where they're at. What that means essentially is what we view a project is how far has it gone through the entire workflow. So you may be able to kind of start a project that you've just gotten to the point where you've incorporated the design inputs, and it would be kind of at the early stages versus something that it's just waiting for final inspection, final CT scan or CMM for a full sign off, and it'd be at a different status. So this kind of tracks that information along with the active projects. Additionally, kind of what you see here on the side are some of the analytic functions that we'll be adding in. The idea here is that because we're tracking things such as material inputs like particle size distribution or kind of melting characteristics, process parameters, laser scan strategies, or nozzle tip, temperatures, as well as the data that's being generated through test specimens, we're able to kind of connect some of that information. And the material science side of me really gets excited about this because it's something that I've had a lot of struggles with just keeping track of, especially as you go to validate processes and make sure that you're operating in a consistent manner. with your system and you're not drifting. So if you're doing tensile bars or some sort of specimen every build or every several builds, you'd have a way to kind of track all that information and see over time, okay, my aluminum silicon mag values are great up until this point. Maybe we can go back and see what changed. So additionally, it allows you to, if you're doing a process validation of density cubes or something like that, you can kind of keep that data organized and structured here. So why don't I go into kind of how a new project works. So if you kind of go here, what I'm going to show is kind of the standard workflow. This is more geared towards a structure around kind of DMLS, powder-based metal systems, but I'll show also kind of the different templates that we have, and we can customize these templates as well. So some of the other kind of working groups that we've got kind of going in this are projects based on FDM technology using Ultem. We're also looking at polymer-based laser sintering using nylon. So all these different workflows have different variables. So it's one of those things that we've kind of incorporated as many as we can into this first launch, with the aim that the folks that are kind of most likely using this may kind of be kind of sequestered to a handful of different technologies. So what you'd be able to do in this process is kind of first identify different elements of just naming and nomenclature, kind of marking kind of what the project is, kind of different numbers. You quickly go into perhaps what standards you're looking to designate. Are you kind of more focused on maybe an FDA spec or kind of more of a guidance? What we'd be able to do then is kind of outline kind of what are those critical requirements that one of those standards documents may outline for additive manufacturing. So with this, you kind of see that the rest of the kind of template has been populated to track what can map back to that original standard. So you'd have things like number of files, file names. You can include and upload a build orientation image as well to kind of start that process chain and kind of digital thread. Additionally, there might be things such as critical features, or are you adding test specimens to the build, and what are those test specimens that you would be including in that as well. Kind of as you move forward, you get into kind of more of the details, more of the kind of critical parameters of the materials. So what feedstock material are you using? Who's your vendor for that material? Has the powder been blended? Did you use a specific qualification build set to qualify that material? And what was that? What was your reference? You'd add in things like particle size distribution, morphology images, maybe SEM images if you're doing that level of detail, or DSC images or particle size distribution maps for this. And some folks may not have all of this information, depending on kind of the level of review that they're doing of their components, or kind of what the standards dictate for their specific application. But we're able to kind of tune this specifically to a specific use case as well. So in this case, one of the things you'll notice is like I have to actually type in the batch number here. But depending on the specific site and how we've kind of been doing the current launches so far, is you'd be able to kind of fine tune a lot of this. So if you're only using a EOS system with this type of powder blend, you'd be able to kind of template that a little bit so that you're not having to enter data in every time manually. And we're also working with some of our early collaborators on the OEM front to kind of sync in data directly from machines. But that's a process, and that's something that will take some time. Kind of continuing on in the workflow, what we've aimed to do is kind of organize this in a way that makes sense in terms of the overall workflow of how a facility might kind of be designing the part. So you get into kind of what machine you're using, what's the ID number, what model number might it be, And is there a specific serial number to that? When was it configured last? When was this last software update? Then you get into more the weeds on the actual process parameters, purge gas, oxygen limits, your laser parameter file if you have that, layer thickness, who did it, on what date. Kind of similarly, kind of this is where a lot of the bigger breakdown from what we heard in our listening tour was with elements of tracking information specific to additive parts and processes was, okay, what happens after the build? So depending on the type of process you're using, you may have to do support removal. What was the cooling process like? Was there stress relief required? Was there any other kind of sanding or surface finishing required? You have kind of that information here. You'd be able to include specific SOPs that would be detailed as well, that would be included. Similarly, who did it and what date. Next, you'd get into inspection on both the as-built part, something that's straight from the machine, as well as something that was kind of post-processed, if that's the approach that you're looking for. So you'd be able to add test reports. You can manually enter the tensile strengths, averages, and the elongation, modulus, things like that, that we'd be able to then track in terms of analytics. Finally, you get to review the quality statement before a project ends. Essentially, you have a sign off to say, okay, everything is done, it's inspected, it's reviewed, and the data is entered correctly. And that essentially goes into kind of a completed area. So if you look here, we've got a kind of list of different projects. These are some of the ones in an active mode. So you'd be able to sort them based on, hey, I just want to look at the 17.4 stainless steel builds today. You'd be able to kind of quickly look at that and or look at sorting it by machine usage. You'd also be able to add in your own filters if that wasn't granular enough. Similarly, you'd be able to do the same thing on completed projects. But what I'll show quickly here is how does this work in terms of reviewing the parts after it's been inputted. So if you go to a project, you'll be able to kind of quickly pull down, okay, here's the process record. Here's what we did in terms of materials for it. Any of the process, post-processing would be documented here to quickly kind of go back and pull this up in a matter of seconds. Additionally, what you'd be able to look at is kind of a full report, kind of a quick download of the part, all the part records, quickly synthesized in a PDF format, so you could send it to a customer or have it internally that you have a paper trail specifically. And again, the aim of this is to save some time. So whatever you're kind of looking at here is you'd be able to shorten your time to get to end production and having that kind of full data threat. Additionally, you can that was the full kind of reviewed data input. The other piece of that, you'd be able to do just an executive report, kind of one pager if the full report isn't needed. So kind of the last thing I want to show, two things actually. What you'd be able to do as well is we have kind of different templates. So that was more of a template for DMLS. As I mentioned, we have a feature where you can edit templates depending on the type of technology or even the type of question that you might want to add in the field that you might be documenting. So we work closely with folks to help set this up as optimized as they can for that facility, but then there may be some fine tuning we can build in that's easily built in to optimize that as well. And so the last thing I want to show in this is kind of as we've kind of worked at different facilities and helped set up kind of labs, facilities, production areas, there's a whole lot of documentation that is generated that may not be directly relevant for every build, but still important to have in a centralized way, kind of perspective. So one of those things is, one of those areas is kind of documentation around specific standards that might be referenced. So we have some kind of quick standards that you might be able to kind of look at here, add in, or have the feature to add in some standards that you'd be able to quickly say, okay, here's our kind of some of our safety standards for metals. Similarly, you can add in your data sheets for any materials that you're using, or kind of build information or qualification kind of information that you're looking at. You'd be able to centralize and store your operating procedures for specific machines, safety operating procedures, emergency procedures, things like that, having that in one centralized place so that everyone in the facility is aware, and you can share that with EHS or any of your kind of safety team as well. Similarly, kind of maintenance and when our machines due for maintenance, when they're worth less, or be able to have that in a quick reference way. And finally, any equipment information, regardless whether it's kind of critical, the actual printing equipment or the ancillary equipment would be able to kind of be documented here. So kind of the aim of this is to have kind of that information that's floating around these different islands in an additive manufacturing facility, kind of centralized to one place in a way and in a workflow that's manageable for multiple different people, and can be used by a lot of different people for different kind of levels of information. You have maybe your design folks kind of can keep a track on kind of what the other parts of the process are. You might have your material scientists looking at, okay, how is our material performing over time with different parts and different kind of feedstocks. You have your quality engineers looking over the entire process. Safety folks may be looking at maintaining operating procedures. Facilities folks may be looking at kind of when was this machine last served. So this is kind of really allows kind of a full view of that, kind of the operations level of the facility. And in doing so, we have a team function that allows each facility to have a kind of admin that can dole out users that can see and view different elements of trace and upload and input data as needed. So so that's kind of the demo I wanted to do. Well, going back to kind of the application itself, just some slides to kind of finish out this thread. Here is in terms of outputs on the database, we use a SQL database, so the information that's stored in here can be referenced, cross-referenced, and as I mentioned, we're putting in kind of some more detailed analytics that are based on our kind of material science expertise and expertise in comparing process parameters with materials and mechanical properties. So you'd have a kind of within all of that, you have sort of a list of projects with all the data kind of incorporated, easily reporting for quality control and project efficiency, kind of dashboard of where projects are and aren't throughout the entire process, and then these cumulative quality measurements. So both in terms of quality, as well as tracking things like material usage, so in the overall process. And as I mentioned, security is important for us. We've got kind of industry standard cloud-based security controls put in place. It's compartmented multi-tenant data storage, so there's no commingling of information between kind of users, and we create specific protocols in place to avoid that. We have configurable multi-layer access controls, whether that's through the administrator, doing things like two-factor authentication or whitelisting specific servers and IP addresses so that only kind of recognized and secure logins can access the information. And then depending on the site requirements, we also have enhanced security packages available. So kind of just to end with a last couple, a few thoughts here, and then we'll take some questions if we do have some time. So if 3D printing is in your kind of manufacturing strategy, quality management inevitably comes up in these conversations. So trace is kind of one of those answers, and we've gone through this in multiple ways, just to have kind of everything centralized so that you can talk intelligently about how you're approaching 3D printing, quality management in a comprehensive way, not only from the parts you're building, but also the operation of your facility and the safety of the folks that are kind of building the parts and doing the entire operation workflow. So in kind of our experience, it's very costly and time consuming to build this custom software from scratch. So kind of let us do that for you, and we've done that in a variety of ways, and looking to collaborate with even more folks to continue to build this out. And the other fact of the matter is that standards are continually evolving. So let us keep up to date with them and help you kind of leverage those in a way that makes sense for different organizations, different industries, and as those continue to evolve, we're aiming to be on many of those conversations and looking to help continue to move the industry forward, help kind of raise the effective use of additive manufacturing for a variety of industries and a variety of production applications. So just to give you a sense of our current path, we've actually installed Trace at a number of different demonstration facilities, both using metal, additive manufacturing, and polymer-based systems. We are continuing to do kind of a light pilot program. We're kind of wrapping that up soon as we go to kind of launch in the next month, actually at AMUG. So any of you that are going to be at the show, we'll have a booth there in one of the main rooms. We'll be showing kind of more demonstrations of what we've been doing, especially around kind of actual tracking of individual components back to the data that we've been generating from here, as well as some new features. So I encourage you, if you are going to the show, definitely stop by or reach out to me in advance, and we can set up some time to meet and talk more about whether it might make sense to incorporate Trace into your facility operations. And so with that, I'll kind of leave some room for questions. I think you can add in some questions either through the dialog box, or I think you can unmute as well. So my contact information is here. It's Mike at 3degreescompany.com. My phone number is there as well. And you'll be able to kind of reach me that way. So I appreciate your time and taking the afternoon to spend it with us talking about Trace. I hope you enjoyed it and hope you find it useful. And as I mentioned, we're looking for folks to incorporate the tool, and especially those who are in the stage kind of giving us quality feedback. I mean, we're not perfect. We're learning as we go in terms of making sure that we incorporate as much as we can in a way that's keeping up with best practices. So we welcome feedback. We welcome kind of insightful conversation on what we might improve or what your experience has been. So any of those, we're happy to set up another conversation and talk more. So thank you for your time. And right now I'll kind of leave it for questions. I think we've got some here. So from Carl, is there an interface that allows for collection of data that goes directly from the build records? So at the moment, no, but what we are doing in this is to look at, so actually addressing that in two different ways. So the first one is we're actually working with a number of OEMs to kind of get data directly from those machines. There are a lot of systems out there, so making sure that we've had conversations with the top folks to make sure that we are trying to work through agreements and kind of paperwork to get some of that information out. But at the moment, we don't have that functionality. We're aiming to do that in the next few iterations of Trace. But at the same time, we've also developed an API that we can kind of push and pull data directly, either from Trace into something else, or data from other interfaces into Trace. So that is something we're actively working on, and we want to make sure that data collection is easy and simple, and that's a big part of it. So not only are we looking at the machines themselves, or the printers themselves, but we're also looking at some of the test specimen interfaces, tensile strength, or perhaps particle size distribution. So all those interfaces just take time, and depending on the sophistication of the interface, it's a little bit cumbersome. But we're doing the best we can to make sure that that's as easy as possible for the end user. So, so if there's maybe 10 more seconds for any other questions. If not, feel free to email me, reach out, and we'll look forward to seeing you perhaps at AMUG, and we'll also be at Rapid in a few months. I think that's in May up in Detroit. So we'll be making the rounds at a number of the trade shows and different meetings, whether it's American Makes or some of the ASTM meetings coming up. So we'll be around and would be happy to talk more about the tool and what we're working on. So I don't see any more questions, but thank you for your time, and I look forward to hopefully connecting soon. Thanks so much.